Alright, it's time for another math easy solution. Time to discuss further into trigonometric substitution for integrals, and now go over example 6, which is this one right here. Looks pretty complicated, which is integral from 0 to 3 times square root 3 all over 2 of x cubed divided by 4x squared plus 9 to the power of 3 over 2, and dx there. Now this looks pretty complicated, and it doesn't look like the form that we're used to. Basically, I'll write it like I've said over here. Now this is still not in the form that we used to for our trig in our trig substitution tables, but we could rewrite this further because, as you can see, it kind of resembles the trig substitution expressions that we used in my earlier videos. Basically, if we rewrite this right here, 4x plus 9 3 over 2. Yeah, if we were to rewrite this as, because we could rewrite this simply as square root, and this is going to be 4x squared plus 9, and this is all to the power of 3. Because remember, square root is the same thing as the power of 1/2, and this is just using power properties, so we could write it like this. So now that we have this part right here, but it's still not in the form that we're used to. But if we rewrite this further, so we just take the square root out only, 4x squared plus 9, this equals 2, well the 4 is just 2 squared, so that's just 2 squared, x squared plus now this 9 is just 3 squared. So this equals 2, put the 2 together, so we have 2x, and now we have a squared plus 3 squared. So as you can see, this is still not the form that we're used to, but this is pretty close. So if we use a substitution t equals to 2x, then we get basically square root of, this is now t squared plus 3 squared. And now this is in the form that we're used to. Yeah, this is a form that we are used to, and now from my earlier videos on trig substitution, from the table you could see that the appropriate trig substitution to apply here is actually we're using t, so t is equal to, this is going to be 3 times it by tan theta. But now to get back to the x, so number t equals to 2x, so this equals 2x, so the appropriate substitution in terms of x is just x equals 2, just divide this out, 3 over 2 tan theta. And now when we have this substitution, now if we look at the derivative dx, that's just going to be 3 over 2, and now we have a secant squared theta and then a d theta. And also, since this is a definite integral we're dealing with, we got to find out these values in terms of theta instead. So at x equals to 0, we get basically right here 0 is equal to 3 over 2 tan theta, or tan theta is equal to 0. And if we recall basically the graph of tan, it looks something like this. So this is, I'll write tan theta right here. This is going to look something like this, where it goes up, etc., and it's going to be like this, like that. So at tan theta, and this is at pi over 2, and this is at negative pi over 2. So at 0, tan theta is, theta is just 0. So this is just theta equals to 0. I'll write this down right here. So at x equals 0, theta is equal to 0. And now at basically at x equals 2, 3 times square root 3 over 2, which is this term right here, then we get basically 3 over here equals to, equals to 3 over 2 tan theta. So scrolling back up to here, that's because there's a 3 over 2 there. So basically we have this now, and now these cancel, and the 2's cancel, so we're left with now tan theta, which equals to square root 3. And you could write this as, well, this is definition is just opposite over adjacent of a right angle triangle. And now this equals to, you could even further write it, square root 3 over 1. It's the same thing. And now we got to find out what this angle theta is. And now this is in the form of the exact trig ratio. Yes, now if we recall our exact trig ratios, which I did a while back in my earlier video, basically using this square root 3 over 1. So let's just draw an angle like this. Well, square root 3 is greater than 1, so I'll write that first. Square root 3 is greater than 1, so the angle is going to be something like this. What is this? Theta. This is going to be square root 3. This is 1. Now this part right here, that is just going to be, well, yeah, this is going to be square root 3 squared plus 1 squared all square root. This equals 2. This is going to be 3 plus 1, so 4. This equals to 2. So this hypotenuse is equal to 2. And if you were to recall, yeah, from my earlier video, when you have this 3, because this is on the on the opposite, this angle right here is going to equal to, well, 60 degrees, which in radians that's just going to be, yep, pi over 3 radians. And a good way to remember is using a rectangle such as this right here, where if you would draw this, if this is 30, actually, if this is 60 degrees, this is going to be 90, so this has to be 30. And now we'll be dealing with, this will be a square root 3, this is square root 3, this is a 1, 1. So if the opposite is 1, and this is a 2 in the hypotenuse, if the opposite is 1, then you have 30 degrees, but if opposite is square root 3, which is greater, then you have 60 degrees, which is just pi over 3 radians. So we have that over here. So we write, well, theta is equal to pi over 3. Yeah, so now we have basically theta is going to be, well, less than equal to pi over 3. And then it's greater than equal to, well, 0. So when we scroll back up, so we have from pi over 3, and now there's a 0 right there. And as you can see from here, this is going like this. So we have tan theta is always greater than 0. Yeah, and this basically fits within here. So now we can go ahead and simplify this square root function right here. So we have this 4x squared, plus 9. Now this equals 2 when we plug in our x is equal to 3 over 2 tan theta. So plug this inside, we get 4 times, now there's going to be 3 squared over 2 squared times it by tan squared theta plus, well, this is going to be 3 squared. Now as you can see here, this is 2 squared, that's 4, this cancels with a 4. Now if we factor out this square 3 squared, we get 3 squared, and now we have a tan squared theta plus 1. And now this equals to, if we just square out this right here, this is going to be 3. And now this, using our trig identity, this equals to, well, secant squared theta. So this just equals to square root now secant squared theta, which equals to 3 times it by, well, absolute value of secant theta. But also now if we recall the graph of theta, so if we have right here, let's call this y. Let's draw what we know is, we can easily know what the cosine theta is. So if this is cosine theta, then we know, well, the secant is just 1 divided by it. So at 1 divided by 1 is 1. At 0, we go to infinity. So it goes something like this. It goes like that. So this is, right here is secant theta. And now at this point right here at the 0, that's just going to be, well, pi over 2. And then, so we know that the limits are from 0 to pi over 3. So we have somewhere, let's say here, pi over 3. So as you can see, this is greater than 0. So this is greater than 0 at, basically, between theta is less than equal to pi over 3 and greater than 0. So we could remove this absolute value. Again, this has to be absolute value because inside a square root function has to be positive. Yeah, so this whole function is always positive, so it can't equal to a negative number. So nothing inside can be negative. Yeah, for real numbers. Okay, so now then this just becomes, well, because it's positive, we can remove that absolute value. So this equals to 3 secant theta. Yeah, okay, so now we have all of the terms we need to replace our current function. So what we could do now is rewrite this 0, 3, square root of 3 over 2 of x cubed over 4x squared plus 9. This is 3 over 2 now, dx. Now this equals 2. If we replace this, now this is going to be from 0 to pi over 3. And now this x cubed is going to be, well, that's going to be 3 cubed over 2 cubed times it by tan cubed theta, because we just put a 3 over 2 tan theta there. And now this bottom part is going to be, well, it's going to be all to the power of 3. So this is going to be here, which is going to be, well, 3 to the power of 3 times it by secant theta to the power of 3. Because inside this bracket with the square root is 3 secant theta, which is right here. Now we just do the power of 3 on it. So now our dx, we just got to find the dx again. So if we scroll all the way back, our dx is 3 over 2 secant squared theta d theta. So now we throw this back in. So we get all the way down here times it by 3 over 2 secant squared theta d theta. So now that we have this, what we could do is, well, we could cancel, let's say, this part right here and this part. Then this 2 to the 3 will add up with this 2 to be 2 to the 4. And now what we also have is this can cancel. And now this will cancel, we're just left with 1 secant theta. So this all equals to integral from 0 to pi over 3. And now we have this right here, which is a 1 divided by 2 to the 4 times it by, so we just took that constant out. Actually, there's a 3 as well. Put the 3 back. So there's a 3 over 2 to the power of 4 times it by tan cubed theta all over secant theta. And now this 2 to the 4, that equals to, oh, so there's a d theta right there. So 2 to the 4 is 2 times 2 is 4, times 2 is 8, times 2 again is 16. So this will just equal to 3 over 16 from 0 to pi over 3 of tan theta, d theta over secant theta. And now it's still pretty complicated, but if we simplified this tan theta, if we rewrite this in terms of cosine and sine, because we're used to that, so basically we know that tan 3 theta is equal, divided by secant theta is equal to, well, this is going to be sine cubed theta over cosine cubed theta all divided by, the bottom one's going to be, well, 1 divided by cosine theta. So this will go on top. This is because they're divided by 1 divided by it. So what we get is equal to sine cubed theta over, these will cancel right here. So this will just be cos 2 theta. So now if we throw this back inside, we get equals to 3, oh, let's put this here, arrow, 3 over 16. Yeah, so this equals to 3 over 16 times it by 0, pi over 3. Now we have a sine cubed theta over cosine squared theta d theta. And now notice what we'll do here, because we're going to have to use substitution again, but just regular substitution. But if we write this sine cubed such that we get rid of this cube, then we also get a sine squared, and we'll use trig identity to make it a cosine squared. So if we write this as 0 to pi over 3, now this will be equal to sine squared theta over cosine squared theta, and now we have a sine right here. Yeah, and you can see more tips on solving integrals of trig in my earlier videos, basically. So now what we do here, this part right here, using the trig identity, this equals to basically 1 minus cosine squared theta. Yeah, so this all equals 2, 3 over 16, 0, pi over 3. Now we have a 1 minus cosine squared theta. And I'll show you why we're doing this. So there's the sine theta. And now the reason we're doing this is because when we apply another substitution, just regular substitution, so let u equals to cosine theta, then the derivative, du, this just equals 2, well, derivative of cosine is just negative sine theta, and now d theta. So basically we have this du, so basically replacing this right here. Or in other words, we have negative du is equal to sine theta d theta. So this completely replaces this right here, and now this u replaces this cosine, so we're not dealing with trig anymore. So if we do that, and now at theta is equal to 0, so at theta is equal to 0, we have u equals to cosine 0, which equals to, well, 1. And you can see that graph here actually, so that's just 1. That's just cosine right there. And now at theta is equal to pi over 3, which is the outer limit right here, or the outer limit there. That equals to, well, u is equal to cosine pi over 3, which equals 2. Well, we could just scroll up here, because we know that, cosine is equal to, well, adjacent over hypotenuse of a right angle triangle. So, and that's angle pi over 3. So if we scroll all the way back up here, so that's this angle right here. This is pi over 3. So adjacent over hypotenuse is just 1 over 2, or cosine of pi over 3 is equal to 1 over 2. So that's adjacent over hypotenuse. So this equals 2, 1 over 2. So now we have u going from 0 to 1 over 2. Actually, I mean not 0. I mean it goes from 1 to 1 over 2. So it goes backwards, but it doesn't matter when you're dealing with integral, as long as it's a one-to-one function. Yeah, so thus if we put this all together, we get integral. So now this is the what we have right here. So from, this is 3 over 16, from 0 to pi over 3 of 1 minus cosine squared theta over cosine squared theta. Now this is a sine theta d theta. This equals 2. Now 3 over 16 integral from 1 to 1 over 2 of now 1 minus u squared over u squared, times it by, well, now it's going to be a negative sign, so we could just put a, this is going to be negative now, du. So there's what we have. So now if we simplify this out, just divide these out, so we get now negative 3 over 16, put the negative outside, so 1 to 1 over 2, divide this out, so we get a u to the power of negative 2. This is the same thing as 1 over u squared. I'm just writing this because it's easier to apply the derivative to it. And now this one is just cancelled, so there's 1. And now we have a du. Yeah, and what we could also do is multiply this negative inside here so that we switch the signs. So we'll just do that to make it look a bit neater. So from 1 to 1 over 2 of now 1 minus u negative 2. So we just multiplied the negative 1 or negative inside it. So we have this, and now we can go ahead and solve this integral. So this equals 2. Integral of 1 is just u. Now integral of the a u to the negative 2, just using the power rule for integrals, this is going to be u to the negative 1, now divided by negative 1. Now this is from 1 to 1 over 2. So simplify this further. This is 3 over 16. And now we have this u. Now this negatives cancel, so u plus 1 over u from 1 to 1/2. Now this all equals 2, 3 over 16 times it by, put the 1/2 inside. Now this is be 1 divided by, well, 1/2. And then we subtract, put the 1 inside, so 1 plus, well, 1 divided by 1 is just 1. So we get overall now 3 over 16 times it by This is going to be 1/2 plus, well, 2. Let's just put it up top. Minus, this adds up to 2. So the 2's cancel, and we're left with 3/16 times 1/2. These times up, so 3/32. And that is our answer, and this is pretty extensive. And well, anyways, that's all for today. Hopefully you learned from this pretty ridiculous example. It just keeps going on and on if you follow through the whole way. Yeah, it's pretty good learning experience to see how you could solve such complicated integrals like this using all these different substitutions. Anyways, thanks for watching. Like always, you could download these exact notes in the link below, and stay tuned for another math